So, give me a sec. Mhm. Okay, YouTube's working. LinkedIn should be working in a sec. Okay. Um, Welcome everybody. Today we're gonna continue building the research agent that we were building the first time. I'll try to do a little bit. I have to head out early today, so I'll try to spend this little time here on the introduction and then get right into it. Um, Ooh, music, right? Nope, not this. Sure. Um, so last time we started with the RAG research agent, well, like last Wednesday, and today we're gonna continue that. So what we achieved last time was being able to parse a PDF document and access its contents, well, truncated, but its contents from an API, just like page by page. And today we're gonna keep doing that effort. We're gonna try, and I'm gonna set myself a small goal of like try to be able to like create a function to chunk it into pieces, um, to feed it into the vector database. And then if we have time, I'll start researching into the vector database and how to run it and how it works and everything. And then we can do that next stream. Because then we can put in the chunks that we talked about into embeddings and into the database. But let's get into it. Okay. So we're gonna start with our kind of card of the day. And that is gonna be from set 11, Aladdin on the Edge of Adventure. It's a 3-cost inkable. It has 2 strength, 3 willpower, 2 attack, 3 defense, basically, or 3 life. I feel like that's more accurate. It's a storyborn hero, and it's the effect is quick on his feet. Whenever you play an action, this character gains evasive until the start of your next turn. Only characters with evasive can challenge them. And Quest for 2 lore. It's by the artist Guawi. It's card 81 of 204 in English from set 11. 11 would be Winter Spell. That's this past set. And you can see like there's like winter. So that's like how you can know besides like just the number. It's a common card. It's the lowest rarity, and it's from Disney Arcana. So this card it's alright. So getting evasive is pretty good, but you have to play an action. The stats are kind of okay. I think this would be the same as Jafar Challenger +2 in Steel. This, well, not the same stats. It would be the same as Yelena. I think she's what she's called, purple. Yeah. So it has the same stats as this. It's also inkable, 2/3. This is a pretty decent effect. It has the same stats except the effect is it becomes evasive every time you play an action, which can be good if you're playing a lot of actions. So I'm gonna say this is okay. You can like shape your deck around it, and like there's like red, green action decks. So you could technically like play this and then start playing actions on the next turns, and then just gonna keep being evasive, and you can keep questing for 2 unless they like hit it with like the Sue's card. I forget what it's called. Sue's action card, Larcana. And then along came Sue's. Wait, no, not this one. There's another one. You deal 4 damage. He hurled his Thunderbolt. This one. This one would just kill it right away. But it costs 4, so you're not gonna be able to play it until I guess your next turn, or if you're going first. I'd say it's pretty decent. If you shape your deck around it or playing a lot of actions, you can quest for a lot before somebody's able to take it out. But that's it for the Lorcana card today, and then let's jump into the code. Maybe a little bit smaller. Lit rag. Oh, right. Okay. Now I'm gonna open a Copilot session to. Well, no, not a Copilot session. Let's use Claude like we were doing last time. Let's see. The story went up. Yeah. Okay. Add files. Skill creator. I should sometime get into the idea because I still have creating skills and using Claude. Maybe that could be one of the streams, like learning how to set up your agent environment. But for now, okay, so I realized that what I did last time, I kind of like pasted the code from Claude and didn't really review it. I still have a general idea of how it works. But let's check it out together. So this is from core? Yeah, this is from my core packages. Using directive is unnecessary. Sure. Okay. Well, so in here we have a class called class 1. We should actually rename this to what would be appropriate. So we're gonna call this PDF management. Maybe something that sounds like mango. Sure, PDF manager. And there's like this read PDF, where right now we just return the first 500 words. We take the first 500 words and then we return them. That's what this does. What we should maybe actually do is return this enumerable. Like we return an enumerable for each page, and then they can just go through it. So it's like a very easy abstraction of like this PDF document thing. Because then it lets the caller to do a little bit more stuff. So page info in this case is going to be a list of enumerable of word. And so then here we're going to add just the words. All of them. Now we don't need this. And then we're returning test page info. So instead of this, we're going to return a list of enumerable of word. Okay, so I need to figure out what this is. Collections, enumerable, LT. Exposes the enumerator, supports the multiple. Okay. Okay, let's look it up. Explain the enumerable interface to me, especially how it relates to PDF management through PDFpig in C#. Simple ones, most important interfaces on that sequence of things you can iterate for. So it's an iterable. Yeah, I could figure that much. It gets an enumerator. Enumerator. Move next, reset. When you write this, you get the enumerator, and then while move next, because this returns false at some point. So it's like a Python enumerator. That makes sense. And this is the enumerator that current, so it's like an iterator. For each, it's just a syntactic sugar or the enumerable. The for lazy execution, this is the most important part. Turn Don't compute all the resorts up front, they compute values on demand as you iterate. Yeah, that makes sense. So it's like an HTTP request where you don't like get the whole thing immediately. You have to because it could be streaming, right? So it gives you like a pointer to get the content, and then you get it as it's streaming. That's what in like JavaScript, that's an async. And then you have to like actually do like JSON dot, no, it's not JSON dot load. It's response.json. You have to do that to get the content. It doesn't give it to you automatically because it's streaming it. And same with this. Well, in this case, you're not streaming it, but instead, you don't want to load that whole thing into memory because it can be very expensive to load into memory. So you just want to hold it, like load it as you ask for it. Calling document get pages doesn't load and parse every page into memory immediately. Pages get produced as you consume them in the loop. Same idea applies to page like words, page like images. You can enumerate all pages in a document using that. So you can iterate over that. I guess you can iterate over the words too. If I did something, let's see. If I have this enumerable, I could technically do for each word in words dot get words. Wait, document is a PDF document, and then you have the get pages, and that gives you an enumerable. So it would be in page.getWords, I guess. So you can iterate over this. Or like if I wanted to do it easier, I could do for each word in words, which is already enumerable, so it just calls words dot what is the method? Move next. Is it move next? Oh, I have to get the numerator and then move next. There we go. So something like that. But we're gonna keep we're not gonna iterate over this, but we know that we can. So it's just an iterator basically. And return the page info. Now the chunker, it should probably be in its own class. Also, we gotta rename this class, so let's go up here and then rename. We're gonna call it PDF manager.cs. That's where our class is called now. And now, let's go to the API. And like this makes sense. Because now instead of class 1, we're gonna call PDF manager dot read PDF. And what's the problem here? Into a list of strings, so we're gonna, it's an enumerable of words. We'll just call it using uglytoad.pdfpig.content. Now here we word. Okay. So I guess the using directive, what it does is it's like using this namespace, so I can call the methods in that namespace directly. Well, not methods in this case. In this case, it's a type, it's a class. So I can use it directly instead of calling every time I use it ugly toad, whatever. The problem with that is you can have conflicting names, like if there's a word defined in some place and a word defined in some other place, and like there's the conflicting names. I don't know how that would work. I should read on that maybe later, but this is good to know. So we have the pages, or I guess, yeah, we have it's a list of pages, and here, so it would be for each enumerable of word or page in pages. Does that work? Yes. So you can't iterate over lists, so it must have some sort of iterator. So for each page in page, we'll create a list of string, which is what we're actually going to end up calling. And this is our response. And so what we're going to do, let's paste this down here, because what we're going to return is a response here. Use them and assign local value with resp. Sure. So here we're gonna do resp.add page.get.take, I think is what it's using, 500. Take. Don't specify the number of contiguous elements for the start of a sequence. So we take 500. We take the face 500 words, and then we join them because this returns. What does it return? Oh, an enumerable. Look at the specified. Okay. So here we're gonna join it. So strings dot join. String dot join. We're gonna join them with, because these are gonna be words. We're gonna join them with a space. Oh, let's do that, I guess. Call out some biggest between the following methods: string join, string, and string join read only. Collection initialization can be simplified. Oh, there we go. Oh, and it says this is yep, and it says this is ambiguous between you join. Oh, my parentheses are wrong. There we go. Okay, so we add that to our response and we return the response. Now our app should run the same. So I create another window. It's going to be where we're going to run our terminal stuff. Personal. And then .NET run source litrag API. Program.cs. Maybe. Type of namespace could not be found. Are you missing a using or assembly reference? Okay. So source litrag API program.cs. So 1 and 2, the type using. Okay, this was working last time. Okay, what if we follow what it says and then basically just delete them? The name web application does not exist in the current context. It's in 1.15. Okay, let me see what I had before in the GitHub. Because I'm still confused about how packages are managed. API program.cs. We had this. Only that. Okay, see, but this is what I had before, and now it says could not be found. Okay, let me see what the run. Maybe I'm passing the wrong command. Did I look this up last time? Let's ask. Maybe I had a Copilot thing. Oh, I don't have. What if I just type Copilot? I don't have an install, so I didn't have a Copilot thing. Uh, it would be here. I guess how do you run the API in a .NET project? Assume it's inside source litrag.api program.6. Ooh, I had this. I had the minus minus project. Okay, so 5278, and now we look up that PDF, and it should be doing the same. Yeah, so it's doing the same thing. We just refactored it a little bit, so now it's a little bit more clean. And now we're gonna chunk. So in our core, I don't know if this is how you actually like organize it, but we're gonna create a new file, and it's gonna be our chunker. Let me think. You should be able to pass it. Would you pass it like a whole string? Maybe not. Because technically we could join this and it could be one big string. I think it can probably handle it. Okay, maybe let's keep working with that PDF manager class. And now, so we have read PDF, which just returns, it just returns an array of pages that you can read over. But now we create also a public static. It's gonna return chunks. It's gonna return chunks, so it should be a list of strings. And it's gonna be called chunk PDF. So it's gonna receive two things. It's gonna receive a PDF document. Should it receive a path? And then it can do the actual logic. Sure, let's continue with that logic. So let's say it receives a path, and then we're gonna determine the chunk size. And should that be in characters? Should that be in characters? No, I feel like it should be in words. But then what if you cut in the middle of a paragraph? Is that okay? I don't know. I don't have enough familiarity with this. We're gonna ask Claude. I'm gonna say nah, we're just gonna ask it without context. So how do you manage chunking a PDF document for a RAG agent? How do you determine where to chunk? Do you determine your chunk size in words, characters, megabytes, or what? Chunking is one of those places where the right answer depends heavily on what you're optimizing for. There's a fairly well-established approach. Let me break it down for decision points. Tokens. Context limit defined in tokens, not words or bytes. If you chunk by word count or character count, you're guessing a token count. And that gets worse with technical text. Equations, citations, jargon tend to tokenize less efficiently than everyday prose. You don't get free tokenizer the way Python has tick token. You have options. Sharp token. I don't know this part yet, so I think we're gonna 2 to 500 tokens per chunk with a 10 to 20% overlap between consecutive chunks. Ooh, okay, this is gonna be interesting to implement. Chunks lose context, embeddings become noisy fragments. Retrieval returns technically relevant but useless snippets. Embeddings get diluted. 3 different ideas. It says 3 to 400 token range. Okay, I'm not gonna see the actual implementation because I want to do that myself. Paragraph breaks, sentence breaks, word breaks. This is nice. I feel like that's what I would go with. Oh, by sections? See, this would be nice. Text section headers via that, then recursively chunk within each section using the sentence boundary splitter above, inspecting the token budget. Yeah, this makes sense. Pairs footers repeating on every page. Multi-column layout. Oh, okay. References section. So yeah, we would exclude this. Okay. So let's do the most basic way to begin. So after we're gonna have to focus on like detecting sections and chunking in between them. But before that, let's just create a very simple chunker. So we have our string. Then let's define in characters our chunk size. This would be in characters. And then an overlap of characters between chunks. Okay, so I'm going to add a comment here. So chunk size and overlap are number of characters. So maybe let's put this in a different way. Chunk size, number of characters each chunk should be, and then overlap, number of characters that overlap between adjacent chunks. Okay. Actually, let's not do characters. Let's do words, because we don't want to leave like a word half in between, right? So number of words each chunk should be, number of words that overlap between adjacent chunks. So we get the path, so we're gonna copy a little bit of here. Let's just copy this for now. We're gonna return a list of string, which are gonna be our chunks. So let's close this. So we have each of our pages. Page dot, we have that get words. Okay. Okay, so we're gonna, okay, I got it. So we're gonna determine like a left and right pointer. Left equals 0. R equals, to begin our chunk size. Right? So if we say we want a chunk size of 3, so the slice would go from 0 to 3, not including the final part. This is very similar to how Python does it. So now here, how do you do slices? How do you slice? How do you slice this? Sure. So you put it into a list, and then you, okay, so this is how slicing works. Wait, what if we don't get it by pages? Like get. Can we just get the words? No, we need to get it page by page. What if we can't be loading the whole document into memory? This is tricky. This is tricky because this if you're doing it per pages, then if you're trying to chunk a page and then you run out of words, then you have to account for those words you ran out of. And then when you're doing the overlap, we would have to go back a page to get the overlap, and that could be one situation. Oh. Okay, what if we ignore the overlap for now? And we'll figure that out in a second. So we just have to figure out one problem to begin with. So for our page, so what happens? Okay, because if we do this page by page, I think it's fine. Skip 10, take 20. Actually chunking. Non-overlapping. So we have this. So to do the chunks with non-overlapping. But then you have a problem is, what if we want to do overlapping, then you have to create your own thing. If, okay. If overlap is bigger than size. Yeah, and buffer that add item for item and source. Okay, so I read only list. I don't know what this is. You need a custom windowing numerator, sliding window. So I'm gonna make this, but like not generic. I'm gonna make it specific to our use case, just so I understand a little bit better. For each item and source, so for each word, you add it to the buffer. And then in buffer the count equals size. Turn a buffer to array. Remove range. Oh. Okay, I understand. Okay, so we'll create, I guess, a private method here. So instead of this, what we're gonna do is but we have to do this over pages. So okay, I think I got it. So okay, let's make our buffer. So we're gonna create a list of words. Would it be a list of words? It would be a list of T. Yeah, let's do a list of word. And it's gonna be called our buffer. and it's gonna be of size chunk size. Must declare a body because it is not marked static extern. You can call it, also there's var buff equals new. So I guess here I'm not instantiating. Okay, is that how that works? Nope. I'm confused with this var. Like, is it just when you don't want to declare the type? So technically just put here, like, list of word. Okay. I feel like it might be clear. I know it can be simplified, but maybe let's do this then. There we go. So this is our buffer. And now we just read the whole document and then we add things for our chunk size. So we say buff.add source would be a page in this case. So for word in page.get words, buff.add word, so we add the word, and then here if buff dot size buff dot count, number of elements, okay, is equal to our chunk size. Then page info dot add so it's going to be strings dot join. We're going to join with a space, and what are we going to join? We're going to join our buffer dot to array to list. And then after that, we're gonna do this buffer remove range. Buff remove range, which removes a range of elements from the list. What other removes are there? Okay, remove range from 0 to our step. Size minus overlap. Are we doing overlap yet? We're not doing overlap yet, so we're just gonna say check size. So okay, this is that part, and now to actually do the overlap, if the count is bigger than 0, then we flush the remainder. Yeah, that's important. If buff.count does not equal 0, let's flush the remaining. Page info dot add string dot join buff to list. Yield return buffer to array. I don't know what this yield return. Oh, this is, yeah, I don't know what this does. We're doing it differently, so we don't have to worry about that. And then we return our page info, which should probably not be called page info anymore, but should be called chunks. So this does it without the overlap. Now let's do it with the overlap. So we're removing our range. It's not chunk size, it's chunk size minus overlap. Does that fix it? So maybe I'll visualize what I'm doing. This is a smart way to do it. I would have done like a left and right pointer, but yeah, that works. So we're keeping, so okay, this is our document, right? And then it has multiple pages, so we'll just say one of many. So what we're doing is we have a buffer. A buffer is just like a list of a delimited size. In this case, our delimited size is our chunk size. So we're gonna call size equals chunk size. So we start reading the document word by word. So word. We just read it word by word. And then we start putting these words inside the buffer. So W1, W2, W of size. Right? Once we've reached this W size, the end of the, like, we filled this whole buffer that we know is the size that we want for a chunk size, we're going to basically remove some elements. So we're not, if our overlap was 0, we just like clear, so our solution is going to be returned, like we have a list which are chunks. We flush out whatever we have in here. We flush it out into our chunks. This is a whole chunk we've done. We put it in our chunks and then we remove it. However, if we have some overlap, we don't want to flush out the whole thing. We want to flush out, let's say this is the overlap I want. We still put this whole thing in here, but then we just remove this part. And so this is gonna just like move all the elements down the line, and then we can keep adding. So we're keeping the overlap part in the next one. And that's how we build our chunks. Okay. So we have this chunk PDF thing. Now what we're gonna do is we're gonna go into our API. And this is PDF, which returns like the first 500, let's say. Let's make another route, and it's going to be called chunk. And we're going to use the same document. And instead of all this, we're just going to return result okay, but it's going to be just a path. We're going to return chunk PDF, I guess. chunk PDF of path. Wait, here we're not, yeah, PDF manager that read PDF, so we need to PDF manager dot chunk PDF. And it's PDF manager like this. There's no argument chunk size. Oh, let's say our chunk size is, how many words do we want? Set 3 to 400. Let's do 350 words. And we want to chunk like 10% into 20%, so let's do 50 words of overlap. Okay. Now let's go here. Let's cancel that. Do it again. Okay. And now here, instead of here, we can go to chunk. And now we get chunks of the whole thing. Is there 3D print? So this should be 350 words. And then let's see if there's overlap. It says overlap of 50 words. It starts with and diseases. Yeah, so I can see here it's overlapping from here on out. And then to what? And then it's I-32. So yeah, it's overlapping properly. Right here, unique challenges, and then actually here, distribution over topics. There we go. And then let's say here, representative of each topic. Okay, so we have a chunker working. And yeah, I think that's good for today. Like I mentioned, I have to call it early today. But I think for next time, I'm gonna try to look into chunking like it said at the beginning here, which is, okay, first of all, we have to ignore, for example, the reference section, so we need to find a way to do that. Second of all, there's this third approach I was talking about. So figure out what the boundaries for the paper are, so abstract, introduction, methods, results, that stuff. And then use that to chunk it. So personally chunk within each section using sentence boundary splitter above. So we chunk sentences. And then it gave us this code. We can basically try to do this. So what we do is we separate the text into sections. So we're going to have to create a different function for separating into sections. And then once we've separated into sections, we chunk it in this way. So paragraph breaks, sentence breaks, word breaks, last resort. But I think we can skip this last resort thing. Just do sentence breaks. I think we can do sentence breaks. So what we're going to do is, let's... do I have the PDFs easily available? Papers. Okay, let's open one here. So when I'm chunking here, let's see this abstract, right? So I'm gonna determine like an upper limit of what the maximum chunk size can be. So I'm gonna try like chunk this by like a paragraph, which would be this whole thing. If that whole thing is bigger than my max chunk size, then I'm gonna try to split by sentences until by sentence until it fits. So let's say my chunk size is 200 and this is 350 words. Okay, I can't chunk a paragraph because it's too big, but we can chunk us to the last sentence that fits within that 250 word boundary. So let's say it would be here, because this is when the sentence ends. So we can chunk there, and then we chunk the rest, and it's going to be a smaller chunk. But we divide this abstract in two. And we want to do it within sections so it stays semantically correct. We don't want to mix like the abstract with the introduction, if that makes sense. But we'll handle it next time. So what we're going to do is chunk, like divide it, create a function to divide the section somehow, to find like with the introduction, the abstract, all that stuff, and separate it. And then create a function that chunks by paragraph first and by sentence second. Okay? But we'll do that all next stream. For now, let me just commit the work that I've done today. Add chunking logic with overlap. And then we push. And technically this shouldn't be words, it should be tokens. So we can also do that next time, where we find like a tokenizer and then separate it by tokens instead of words. But I think words, I mean, yeah, it's weird to do words instead of tokens for the embeddings. We can figure it out eventually, but for now I thought it would be easier to just do tokens. So that's a good trick with your projects. Start small and simple, and then move over towards more complicated stuff. But that's gonna be it for me today. Have to get ready for the concert.